Hello guys, thanks for coming back again. If you're a subscriber of this channel, and if you're yet to subscribe, just click on the subscribe button and also on the notification bell to tell you when we drop a new video. So we want to look at the IJMBE 2024 chemistry practical. This is just a preparatory video to tell us what we might encounter and the similar questions that we might come across. So now let's take a look at this question. Before we start, I need you to understand that you are doing two sets of titration. So which not the first time though, they have been using such method ever since. So now the first one, we have a redox titration. The two is a redox titration. So let's go through the solutions that are provided. You are provided with the following solution. So as you can see, solution A is an hydrated sodium thiosulfate. Then we have solution B, which is aqueous KMNO4. Then we have solution C, which is 10% weight to volume aqueous potassium iodide. Then you have starch D, which is the solution D, which is starch indicator. Then you are provided with a complex salt, which is hydrated. Though no one knows what the question might be, but this is just something to at least brush us up on what we might encounter and how to tackle such question. So we have that complex, double salt with certain number of moles of water of crystallization, of which we are going to look or find the value. Look for the value. So we have solution F, which is aqueous H2SO4 solution, and the purpose of this solution, as you can see here, is to protonate reactions. That means you're going to add maybe a few centimeter cube of it to the content of the conical flask before you start the titration. So let's go through the procedure. A, we have put solution A in the burette, then you pipette solution B. As you can see the solutions here. So we pipette solution B into a clean conical flask and add 10 centimeter cube each of solution C and F. So which means after making 25 centimeter cube of solution B into the conical flask, then we add 10 centimeter cube of solution E and F. Solution C and F rather. Thank you. So we take 10 centimeter cube of solution C and F using the measuring cylinder, and we have that to mix together. So the reaction that takes place in the conical flask is represented with this equation. So this is conical flask. Now the actual reaction is now we're expecting the K high from solution. We're expecting the K high, which is from solution C, to react with KMNO4 in solution B, and in that wise we are going to produce iodine. So while titrating your solution A against the mixture, it is the iodine in that mixture that will then react with the sodium thiosulfate to produce iodine ion. So that is why we have two chemical reactions here. So this one is unbalanced, meanwhile this one too is unbalanced. So the only way to balance it is just to put 2 here, then it will be balanced. It will be balanced. So this have to go through the series of steps of balancing redox equation before it could be balanced. And when you have to balance that equation, you make sure you have your number of moles in contact. Whenever after balancing the equation, that is when you can get your actual number of moles. So then let's move on. So we're told to run solution A from the burette into the content of the conical flask until there is a color change to pale yellow. So at this point where you have a pale yellow, you need to stop the titration immediately and then add few drop of what? Solution D, which is starch. So once you add that, the solution changes to another color, different color. So which is kind of blue black. So then thereafter you now titrate until you have a colorless endpoint. So which means at the point where you have the pale yellow, the titration is about to end. So you need to be very careful in adding the other drops after your indicator has been added. So we are told to repeat the procedure like 2 more times using the new portion of those solutions and calculate our average titer. This experiment has been done, but I cannot show you in this video. I'll show you my table. So now that is the first titration. So I have the table here. That's procedure A. So now let's go to procedure B. In procedure B, we have to wash all the apparatus and then pipette out 25 centimeter cube of solution E. Solution E is now the double salt, which is this. So then thereafter, we take a measuring cylinder and put solution F, which is the acid, to protonate the reaction. Then we rinse the burette with solution B, which is KNO4, and then we fill it with the same solution. Then run solution B from the burette until a permanent pale pink color endpoint is reached. So which means once the color of the mixture of what is in the conical flask and the burette is changing into pale pink, the reaction has ended. So you repeat that one twice to calculate your average titer value. So whatever result we get from all these with our equations and the information provided here is what we are going to use to solve the question that comes after it, which is all these questions. So let me show you my table first and my average titer so we know what to do. So this is the table for the procedure A, and my average titer is 12.03, and this is table for the procedure B, and the average titer is 20.10. So now let's go over to the calculation. So in the first part of the calculation, we were told to find the amount of mole of Na2S2O3 in 1 dm cube of solution A. But take note, you were given in the question, we are given a solution of hydrated sodium thiosulfate, but here you are told to look for the number of moles of sodium thiosulfate, that means the anhydrous, in 1 dm cube. So which means the concentration of anhydrous Na2S2O3 in 1 dm cube. So one thing we need to understand is to answer this question we know that we have Na2S2O3 dot 5H2O, of which we need to know the molar mass of that. The molar mass of that would be 158. So which means molar mass of this is 158 gram per mole. So in that wise, we'll check the percentage of this without this water of crystallization. So that means percentage of Na2S2O3 in A, that is in Na2S2O3.5H2O would be 5 into 18, that's 5 times 18 over 158 times 100, and that gives 63.7%. So with what I have here, it means from the mass of Na2CO3 measured, Na2S2, that means sodium thiosulfate rather. So from this 6.5 gram that was measured in 250, only 63.7% of it will be anhydrous. The rest of the mass would be water of crystallization. So which means what I got to do here is to calculate mass of Na2S2O3 in what? In solution A. So and that will be 63.7% of what? of 6.5. So if I had to do that, I will have 63.7 over 100 times 6.5. So and that gives me 4.14 gram. That is 4.14 gram per dm cube. So this is the mass of the anhydrous. Let's put it this way: the anhydrous in 1 dm cube. But we are told to find the number of moles, so we have to convert this 4.14 into moles, and we use the formula molarity equals mass concentration all over molar mass. Mind you, the molar mass of this is not 158 any longer. It's going to be different. Oh, we have made a mistake here. So the sum of the mass is not 158, is actually 248. 248, but still gives the same answer. So which means the mass of this would be 158. So the molarity, which is the number of moles, so let us call it concentration in mole per dm cube, is going to be that is 4.14 over 158. So with this, I was able to have 0.105 mole per dm cube. So this is actually the number of moles present in 1 dm cube, the number of moles of the anhydrous is present in 1 dm cube of solution A. So now we are now meant to look for the amount in moles of this, that's anhydrous sodium thiosulfate, in average titer. So what is that? To get the number of moles N, that is question I. To get the number of moles, we use the concentration times volume over 1000. So which means the number of moles in average titer is going to be concentration. So we can regard this concentration as Ca. So we call this Ca times Va over 1000. So times Va over 1000. So this would definitely give me so sorry, we need to adjust one or two things in this calculation. So don't forget, this is the mass of anhydrous sodium thiosulfate in 250 according to the question. If you check it, so we're told that this is in 250. So if 6.5 is in 250, so which means this times 4 will be in 1000. So we are supposed to multiply this by 4. So by doing this, so this is not gram per dm cube, so it just be gram in 250. So which means in gram per dm cube, I'll be having a 4.14 times 4. So the value here is now in gram per dm cube. So sorry about that. So I was fortunate to have this to be the same answer, though it won't, but just because I've solved it earlier, so that I was able to get to remember the answer. So now this is it here. So the mass concentration will be the mass in 250 times 4, which will represent the mass in 1000 over 158. So that gives us this. So now the concentration is 0.105 times volume. So the volume, the average titer, don't forget, is 12.03. So we use times 12.03. So with that, so if I divided my answer by 1000, I'll be having 0.00126 moles. So that is the number of moles according to this question that says number of moles in average titer. So now I want to get the amount of moles of KMNO4 used in each titration. So which means in this titration, we use KMNO4 as our B. In this titration, we use KMNO4 as our B as well. So in that wise, we want the volume of KMNO4 used here is 20.10. Then the volume of KMNO4 used here is 25 centimeter cube. So to get the number of moles in each reaction, the number of moles here is going to be what? The concentration of KMNO4 times 25 over 1000. So the number of moles of B here is going to be what? The concentration. Okay, this should be CB, concentration of the KMNO4, CB times, then I will have 20.10 over 1000. So don't forget the concentration will be the same because it's the same solution. We didn't prepare it separately. So how do we get this concentration? So we need to write the balance equation for the reaction. So let me just write the balance equation somewhere here. So for this equation, for the first one, the balanced equation for this first reaction would be MnO4 minus, so the balance equation is 2 of this plus, then we have 8H plus 2I minus going into I2 plus 2Mn2 plus 4H2O. So this is actually the balanced form of the equation. So the number of moles in this reaction, the number of moles of KMNO4 is 2, so we call that NB is 2. So then the second reaction is, check it out, we have I2, are you following now? I2 plus S2O3, 2 minus, so of which I have to put 2 here, going into S4O6, 2 minus, plus, so this is it. You have now the number of moles of, the reaction is between these and these, but we are not given this as a solution. So in calculating the concentration of B, take note we already have concentration of A. So in calculating the concentration of B, NB is 2. So then NA now is going to be 2 here. Okay. So Na is 2 as well. Na is 2 as it is here. But instead of using this, we would be using this number of moles of iodine because it is not KMNO4 that reacted with this, it is iodine. So which means by the virtue of what we have here, we can make our calculations to be CAVA over CBVB equals to NA over NB. So Ca is the concentration which we have just calculated for A, and that is 0.105. So I'll use that as 0.105 times Va, which is the average titer, that is 12.03, all over Cb is what we are actually looking for now, times the volume of B. The volume of B is now 25 in this reaction, so we have 25 equals number of moles of A. I have said that is 2 over number of moles of B. Instead of using 2, we are now going to use 1. So because this does not directly react, it is this. So that we use 1. So from there we'll be able to find our Cb. Mind you, when you write this formula and you're looking for Cb, you need to make Cb the sort of formula before you proceed into substitution. So and that will be CA VA all over NA multiplied by VB. So which means CB would be equals to CA 0.105 times VA 12.03 times NB, which is going to be 1, sorry, all over, then we will be having NA, which is 2, times VB, which is 25. So with what we have here now, we can just punch the calculator and get our answer. So this concentration CB gives us 0.025 mole per dm cube. So that's the concentration. So the number of moles of B in reaction A, in procedure A is going to be the concentration 0.025 times the volume, which is 25.0. Then that's, you have to divide that by 1000. So the number of moles of B in procedure B is going to be 0.025 times, so the average titer, since we use it as these, will be using the average titer here, so we have 20.10. so whatever answer this gives is that. So now the next line is, we're told to calculate the number of moles of this in average titer. So the number of moles of that in average titer is very simpler to calculate. So to get the number of moles of, that's for the second reaction. So I think I was able to get this. Okay, if you have to get the question where I think they said the number of mole used in each titration, so which means that's the concentration we have found. So now if we say the number of mole of KMNO4 in average titer, so that corresponds to this, so which means this over 100 rather, so then this might be relevant as far as the question is concerned. So then the next line of action is going to be to look for this. So meet me in the next slide of the video to see how to solve this. So that is that for such question. So we have these to be the number of moles. So the actual answer for this second titration is going to be 0.02, 0.005 moles. So this is the number of moles of B in the average titer. So now the next side we would go now is, I've said it earlier, so we want to look at how to calculate. We want to look at how to calculate the amount of moles of the amount of moles of the complex salt in 1 dm cube. So we want to calculate the concentration. So now the balance equation of this reaction between this and KMNO4, we could get the number of moles of these to be 10 and the number of moles of KMNO4 to be 2. So which means in this reaction, whose table is here, Ne, which is the complex salts, is going to be 10 if you write the balance equation. So then NB is going to be 2. So we'll start the calculation now. So which means to find the average volume, to find the number of moles of these in mole per dm cube in 1 dm cube, so we'll still use the formula CBVB over CEVE equals to NB over NE. So the CB is the concentration of KMNO4, as we all know, to be 0.025, times VB, which is the average titer, 20.10, 20.10, all over CE, which is the number of moles in 1 dm cube of this particular content of solution E. So which means we'll be having these times, then the VE is going to be 25. So here will be, I've said earlier, so NB is 2. So and the other is, then we have 2 over 10. So now to make CE the set of formula, I make these to be 0.025 times 20.10 times 10 all over 2 times 25. So let's go over to the calculation here and tell the answer. So the answer to this is CE equals 0.10 mole per dm cube. So after having this, so the next is, that's the number of moles in 1 dm cube. So we need to find the molar mass, since we don't know the molar mass, though we know that molarity is equals to mass concentration all over molar mass. Now we have the molarity, which is CE. Now what about the mass concentration? So then we need to go back to the question. So in the question we're told that it contains 10 gram of this salt in 250. So if 10 gram is present in 250, so 10 gram in 250 centimeter cube, so which means M will be in 1000. So this is over 4, so 1 over 4. So then I'll be having 10 over M equals 1 over 4. So M will definitely be what? 40 gram per dm cube. So there will be 40 gram in 1 dm cube for that particular salt. So that 40 gram is the mass concentration. So since we are now looking for the molar mass, so make molar mass the subject of the formula. So the molar mass will be equals to mass concentration all over molarity. So the mass concentration now is 40 divided by the molarity, which is 0.10. So now let's put that into calculation and see what we have. So this actually gives 400 gram per mole. So now the next question now says we should find the value of X here. So to find the value of X, we know that the molar mass of NH42 SO4 FeSO4 dot X H2O now is 400. So which means I would have to find the mass of this, then multiply by X times 18. So what's the mass of this? So this gives 284. So this would be plus 18x equals 400. So which means 18x would be 400 minus 284. So x will be 400 minus 284 over 18. So let's check it out. So x actually gives me 6.44. So that is going to be what? 6. So which means the salt is NH42SO4 FeSO4.6H2O, the way it would be. So thanks for watching. Please subscribe to this channel and endeavor to share our videos. We are going to start treating the JUPEB and IJMBE syllabus apart from the practical videos. So don't forget to share our videos to those that are useful to them and those that might need one or two things to learn. Thanks.